Hello, my name is Atsa here, and my collaborator is Karen Emery. And today I'm going to present two studies that investigated the contribution of lexical quality and American Sign Language skill to reading comprehension in adult deaf signers. And I'm going to describe two studies. The first study examines the relationship between lexical quality variables and reading comprehension. And in the second study, we examine the relationship between American Sign Language variables and reading comprehension. And the goal of these studies is to provide evidence for deaf-specific adaptations of the architecture of the reading system. Hearing children learn to read by mapping the sounds of their spoken language onto the letters of the language they're learning to read. And these phoneme to grapheme connections become crucial for word recognition and reading development. Phonological development is highly correlated with reading development, and the importance of phonological representations may last into adulthood. But deaf readers have reduced or no access to spoken language. There are many deaf readers who go on to become skilled readers. So the question is, what is the nature of their reading processes? Is phonology even necessary for deaf readers to develop skilled reading? Evidence for the use of phonological codes during reading has been mixed in deaf readers. Skilled adult readers have been shown to rely on phonological coding during some tasks like short-term memory recall, but not in other tasks like word recognition. So the use of phonological coding may depend on the task demands. Skilled reading requires high-quality lexical representations that are fully specified. The lexical quality hypothesis derives from the triangle model of word reading. The triangle model assumes cooperative division of labor among orthographic, phonological, and semantic components. The lexical quality hypothesis argues that variation in the quality of these representations has consequences for variation in reading comprehension. Based on this hypothesis, we predicted that a quality of phonological representations will be the primary predictor of reading comprehension for hearing readers. But for deaf readers, who were skilled readers, we predicted that quality of orthographic representations will be the primary predictor of reading comprehension. In addition, due to weaker phonological representations, direct orthographic to semantic mappings may be strengthened for deaf readers. So we might expect that quality of semantic representations might also contribute to reading performance in deaf readers. To assess reading comprehension, we use the revised version of the PIAT test, Peabody Individual Achievement Test, Reading Comprehension Subtest. In this test, participants read silently sentences and subsequently choose one of 4 pictures that best describe the sentence they just read. In Study 1, the research question was to examine the relative contribution of lexical quality variables to reading comprehension. There are many ways to assess lexical quality. We use the following measures. To assess orthographic knowledge, we used a test of receptive spelling. To assess phonological knowledge, we used a test of awareness of sound patterns, and semantic knowledge was assessed using a vocabulary test. We additionally obtained nonverbal reasoning, NVIQ, and included age and years of education. In the test of spelling recognition, Participants see lists of words and are asked to circle words that are spelled incorrectly. There are a total of 88 words in this test. Here is a task example from the phonological awareness test. Participants see a triad of pictures and are asked to think about the sound of words that describe them. Then they select the word containing a sound that is different to the other two items. Thirdly, semantic skill was assessed using a version of the PPVT test, which was adapted for use with deaf individuals. Participants see 4 pictures with a word visually presented in the middle. They match the word with the correct picture. To analyze the data, we used hierarchical linear modeling with multiple steps. In the first step, we entered age and years of education. In the second step, we factored out nonverbal reasoning and VIQ. And the variables in these 2 steps are known to influence reading comprehension. In the final third step, we included the 3 lexical quality variables. The study recruited 2 groups of participants. There were 98 hearing people, English monolingual speakers. The second group were 97 deaf ASL signers, and ASL was their main language of communication. 51 signers were exposed to ASL from birth and had deaf parents. 46 signers were exposed to ASL before age 7 and had hearing parents. Participants in both groups were matched on reading comprehension score. The results for average test performance. Deaf participants did not significantly differ on reading comprehension score and non-verbal reasoning score. But deaf participants outperformed the hearing on spelling test. In contrast, hearing participants scored better on the phonology and vocabulary tests. The correlation analysis reveals that all lexical quality variables were positively correlated with reading comprehension scores, regardless of group status. Better readers have better lexical quality representations overall. The regression results for hearing people are shown in blue color. The top table shows that phonology significantly predicted reading comprehension for hearing readers, above and beyond the remaining variables in the model. In the graph on the right, the beta values are plotted on the y-axis, and the individual variables in the model are shown on the x-axis, like age, education, nonverbal reasoning, and orthography, phonology, and semantics are highlighted in green. The results for deaf participants are shown in purple. And you can see that orthography and semantics were the significant predictors in the model, not phonology. So these results matched our prediction that phonological precision will play a key role in hearing, but not deaf readers. But there are different ways to assess reading comprehension skill. If we used another, unrelated measure of reading comprehension, could we replicate these results? We administered the Woodcock-Johnson passage comprehension test to a subset of 77 deaf and 77 hearing participants from Study 1. And indeed, we again found a lack of the role of phonology in skilled deaf readers, but phonology continued to be significant in the hearing group. To conclude Study 1, in line with our prediction, quality of phonological representations supported skilled reading comprehension in hearing readers. For deaf readers, Quality of orthographic and semantic representations jointly supported skilled reading, not phonology, suggesting less reliance on phonology and more direct links between orthography and semantics for deaf readers. Now, these results were not specific to the PIAT test we used because we successfully replicated these findings using a different test of reading comprehension. Most deaf people in the US know two languages, ASL and written and some spoken English. So we could say that they're bilingual. Sign language proficiency has been consistently linked with skilled reading. Additionally, fingerspelling, as an alternative orthographic system for deaf signers, has been found to predict reading fluency and comprehension. In Study 2, our goal was to evaluate the relative contribution of ASL skill to reading comprehension in deaf people, above and beyond other variables that have been known to influence reading. We assessed three aspects of ASL skill: ASL comprehension, ASL sentence reproduction, and receptive fingerspelling. There are many tests to assess ASL skills. However, only few tests have been standardized. The figure shows two example items from the ASL comprehension test. Participants see a picture or a video on the computer, and below they see 4 items. They use their computer mouse to select the correct matching response. The second measure of ASL skill was the ASL sentence reproduction test. Participants watched increasingly more difficult sentences on the computer screen and were asked to repeat the sentences verbatim. There were 35 sentences in this version of the test. The third measure was the fingerspelling repetition test from VL2. Participants were asked to watch and repeat lists of fingerspelled words. Of the 70 items on the list, there were 45 real words and 25 pseudo words. There were 82 deaf participants included in this study. All were skilled ASL signers. 45 signers learned ASL from birth and had deaf parents, and 37 were exposed to ASL before age 7. All deaf participants were also matched with participants in Study 1 on reading ability. The correlation analysis revealed that performance on all ASL tests significantly positively correlated with reading comprehension. In other words, skilled signers were also better readers. Although ASL skills were associated with better reading in general, in the regression model, only fingerspelling was a significant predictor of variance in reading scores above and beyond other factors, not ASL sentence reproduction and not ASL comprehension. You can see the contribution of the 3 ASL variables in the model highlighted in green. Our results align with previous studies, corroborating the supportive role of fingerspelling in reading attainment. Education methods that incorporate fingerspelling may indeed scaffold print acquisition, and fingerspelling and orthography may be tightly linked. To conclude, these studies provided evidence that reading processes in deaf readers are adaptive, not maladaptive. The architecture of their reading system is just differently organized as a result of their unique educational and language exposure. We use the triangle model to explain that in deaf readers, the division of labor shifts to more direct orthographic to semantic processing, while there is a weaker reliance on phonology during reading comprehension. This study also corroborates the notion that fingerspelling is closely associated with reading skill, which aligns with previous work. Finally, characterizing these reading processes in deaf readers has implications for improving deaf literacy, therapy programs, and re-evaluating theories of reading. Thank you for your attention, and I will take questions.